Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am dealing with thermodynamics. And in this lecture series, this is lecture number 21, which is on determination of internal energy change in different processes. So let us take this one. We have formula dE is equal to del Q minus del W according to first law of thermodynamics. Okay. Now, first of all, we will take cyclic process. This is a cyclic process, for example, where this is initial state as well as final state. So we proceed from initial state to this route. We reach here, then we go ahead. We reach to the point 3 and then we reach to the point 4 and then finally we reach to the point 1 again. So this way it becomes cyclic process. And in cyclic process, you know, del dE is equal to EB minus EA. Matlab final minus initial. We write internal energy of final state minus internal energy of initial state. But in this case, final state is equal to initial state and therefore dE is equal to 0. There is no change in internal energy. Okay, so we write function dE is equal to 0. So according to this state, if we write formula function dE is equal to del Q minus del W, where this is equal to 0, therefore we write del Q is equal to del W. That means the total work obtained is equal to the net heat supplied in cyclic process. Next one is isolated process. Second is isolated process or in isolated system. The process will be adiabatic process. Because in isolated system, nothing is going out, nothing is coming inside the system, and therefore we can say that there is no heat exchange in adiabatic process with the surrounding, and therefore delta Q will be 0. And if delta Q is 0, the formula is dE is equal to delta Q minus delta W. Okay, if delta Q is 0, that means dE is equal to minus delta W, or dE plus delta W is equal to 0. That means the work done by the system would be at the cost of internal energy and equal to the decrease in its energy content. Next will be non-isolated system. So here in non-isolated system, the system gains heat, that is delta Q, and does work, that is delta W. So for this one, delta E system equals to delta Q minus delta W, and for surrounding, it loses delta Q amount of heat but receives delta W units of work. So dE surrounding equals to delta W minus delta Q. So now we make a total of surrounding and system change, internal energy change, then dE system plus dE surrounding would be 0 because these two are opposite. So here we can say that the total energy of universe remains constant. This is first law of thermodynamics. So we can prove first law of thermodynamics mathematically like this. Next system is called isochoric process. So next process is isochoric process. Here in isochoric process there is no change in in isochoric process there is no change in volume. That means delta V will be 0. Okay, if the delta V will be 0, then P delta V is also 0 and P dV is work. So therefore W delta W will be 0. And here if work exchange or change is 0, then internal energy change equals to heat. So this way in isochoric process internal energy can be determined by change of heat. Next one is isobaric process. In isobaric process, there is no change in pressure. So delta P will be 0. That means P remains constant. If P remains constant, W is equal to P delta V. That is change in volume. Therefore, delta E is equal to Q minus P delta V for isobaric process. So this way we can determine internal energy change in different process using first law of thermodynamics. That's it in this lecture. Thank you so much.